Hello everyone and welcome to the session on Pandas. In this session, we are going to be learning about a Python library that is called Pandas. So let's actually start the session. So Pandas is a high-level data manipulation tool which is built on the Numpy package, and its key data structure is called the data frame. Now data frame allows you to store and manipulate tabular data in rows of observation and columns of variables. Now the question arises, why Pandas? Pandas is actually built on top of the Numpy package, meaning a lot of structure of Numpy is used to replicate in Pandas. Data in Pandas is often used to feed statistical analysis in SciPy, plotting functions from matplotlib, and also machine learning algorithms in scikit-learn. But before going directly into data frames, let's also have a look at the one-dimensional array that is called series in Pandas. So we are going to be learning here about the 1D and 2D arrays and their creation in Pandas, manipulation of the data in these arrays, saving my data frame in CSV or Json file, and then how I can access them again. So let's actually start now. So I've already opened up my Jupyter notebook here, and so first things you need to install the Pandas library. So I'm just simply going to say pip install pandas, and this is going to install pandas on my laptop, but since it's already installed, it is going to say requirement already satisfied. Now I'm gonna import the pandas library here as pd and also the numpy library as np. So it's gonna import them. Yeah, now great. So how can you create a series? So a series is created through a pd.series constructor. So let me say here's ser and then pd.series, and yeah, that's how you create an empty series. Now it's giving me a little deprecation warning which I can ignore. So here you'll see that it's an empty series with d type float 64. Now let's create another series with like a single number here, and let's see what it gives us. So it gives us a single value here, and the 0 actually represents the index number, so we'll actually talk about that. Here d type is integer 64. So let's create a series using an array. So let me just randomly put some numbers here. Yeah, so that's enough, and this is going to create a series here. It's of int 64. This is the easiest way how you can create a series. Now there's another thing about it, that you can actually define the d type or the data type for our series by using this d type argument. So I'm just simply going to write here float 64, and let's see what happens. So it actually converts everything here to into float 64 data type. So that is another way of manually providing the data type for the series. So now let's actually talk about indexing. In the output, there are integers on the left hand side of our series element. These integers are collectively known as the index of the series. Now we can also create custom indexes for our series. Let's see how we can actually do that. So let me copy this. Here, let me remove two elements. And then we can use the index argument here, and we can provide a array. So first, second, and third. Now these are going to replace the default indexes that are 0, 1, 2, and 3 by these given indexes. So now instead of 0, 1, 2, 3, we have now first, second, and third. So this is going to basically overwrite that particular thing. So that was enough for series. Now let's actually talk about data frames. So as we talked, the series is essentially a column, and a data frame, it's actually a multi-dimensional table which is made up of a collection of series. Let's create a data frame here from scratch using a dictionary. So let me create a dictionary here. Okay, so I'm going to name it as data. Now what's this dictionary is going to store is basically the data of a company which sells a product, and it is basically for 4 days in a week. So let me say product 1, and then we can have here the data of how many units were sold during a particular time, during a particular day. Then we can have product 2. We can say on Monday it was 25, 87, 96, and only 24. Then So it basically represents the sale on Monday, Tuesday, Wednesday, and Thursday, the 4 days of a week. So here we have created our dictionary. Now let's create a data frame out of it. So to create a data frame out of it, let's just say purchases, the name of our data frame. Then we have to say pt dot data frame, and then we need to provide the dictionary here. So if I just simply provide here the dictionary, and then I also print here the data frame, so if you will see, it has now created our own data frame. Okay, so how did it exactly work? Each key or value item in data corresponds to a column in resulting frame. So basically this is a column here, and the data here is that becomes the column data. So that's how this data frame here is created. Now the index of this data frame was given to us on creation as the numbers 0 to 3. So as you can see here, it is 0 to 3. But we could also create our own when we initialize the data frame. So let me explain you with the example here. Like if we don't want 0, 1 or 2 or 3, we can just simply say like index equals to, and then we can provide like, so for example it was on Monday, we can say Tuesday, we can say Wednesday, and then we can say Thursday. So what it does, it is going to override the default index that was numerical. Now we have Monday, Tuesday, and Wednesday as our index here. So that's kind of great. Now if you'll notice, the indexes are changed from numbers to days, like Monday, Tuesday, Wednesday, and Thursday. It can also be the date on which these deals were made or these sales were made instead of the day. Now we can also locate a particular day here by using the lock property of a data frame like this. So we have to say purchases dot lock, which basically represents location, and then I can say Monday here. Now it will give me the sales that was made on Monday for each product here, for product 1, product 2, and product 3. And we can also do something like this by saying purchases and directly entering the product name here, like product 1, and it is going to give us all the details for Monday, Tuesday, Wednesday, and Thursday. So this is how I accessed it using the label or the column name, and this is how I accessed using the indexes. Okay. Now we can also see the data types of our data frame using the df.dtypes. So if I say here purchases.dtypes, it should give me the data type of all the columns that it has here. So for product 1, it is in 64, product 2 in 64. So basically the data type of our whole data frame is an object. You can also do the same for a particular product here. So if I say like purchases, and then I access like product 1 here, and then I say .dtype, it will actually give me the data type of that particular column. Now I can also create a data frame using the Numpy array. So let me create a data frame using the Numpy array by saying pd.dataframe and then providing a Numpy array. So this is why I imported Numpy 7, 8, 9. So basically what we did, we created this here, and we can also name the columns. So we'll just simply say columns and then provide the column names, and then see. Now just simply say df, it's not purchases. Yeah, so I created a data frame using a Numpy array here. Also the column names are different because I provided the different column names. What I can also do is I can also add an index here if I don't want, like, okay, to provide index, it should be like this: first, then second, and then third. Now you'll see that actually the index has been changed, but I don't want it right now, so I'll just simply remove it here. Yep. Now let's talk about addition and deletion of rows and columns. So rows can be added to a data frame using the append function, which takes in either a series or another data frame. In the case of a series, we either need to specify the index for the series, or we need to use the argument that is called ignore index, and we need to set it to true. That will actually change the row labels to integer indexes. Now let me show you here how it's done. So we already have the data frame here. Now what I'm going to do is I will create another series by using pd.series, and then let's actually provide some data here. So let me provide 70. So I created this series here. Okay, let me also add a name to it, new row. So if you will see, it also tells me that the name is actually new row, and then I just need to say like df2 equals to df dot append, and then we need to say here ser. So let me say here df2, and if you will notice that it actually added it, but like the indexes are different. It added it, but like it was kind of a fail attempt. So let me change here indexes. Let me say A, B, and then C. Now if you will notice, we have got different indexes and we have got a different result here, a totally different result. Now let's talk about the ignore index part. So let me actually copy it and let me paste here, and let me add the ignore index part here. So if I say ignore index and then I set it to true, you will notice a difference. You actually don't care about the row label or the name of the series, but now they have been added, but now they are actually without the row name and they are integer indexes. So that's what ignore index does. It converts the indexes or the row labels to basically integer indexes. Now let's move on to the next part, how we can add a data frame to a data frame. So here I can create another data frame here like this, and let me say here data frame 40 and 150. Now one thing I forgot that I need to put them as an array. So yeah, and then after them I'm gonna give their column name like this. So it's actually A, B, and then C. I hope it's correct. Yep. So we have our data frame here. Now what I'm gonna do is I will append these two here. So I'll say like df4, create a new data frame, df dot append, and then df3, and then let's actually have a look at it. Yep. So if you will notice here that these values have been added here, but the indexes are different. Like again, there is 0, 1. Now if I actually do the same thing again, but with ignore indexes as true, you will notice a difference here. That is, now we have continuous integer index. So that was for appending a data frame to a data frame and a series to a data frame. So now let's start talking about deleting a column or a row. So we can use the drop method here. This method actually allows us to remove columns and rows in a data frame. Now this can be done in one of the two ways. First one, by using the labels argument to specify the label of the row or column that we want to drop or we want to delete. Second, we can directly use the index or columns keyword argument in the function drop to directly remove the column or the row without needing to use the axis. So if you get confused with the axis, you can directly use columns or rows. Okay, so now let me explain you here how we can do that. So let me say if I have a data frame, let me actually create a data frame here. So if we have a data frame, okay, so we have the data frame df4 here, if you can see. So let's actually drop a column from the data frame 4 df4, and then I just have to say drop. Now I need to provide what basis I want to delete. So I'm saying here index equals to 1. So it is going to remove the first index. Let's see. Also, okay, so if you can see, like, it dropped the first index here. Now we can also directly use the labels argument. So if I say df4.drop and then I say labels equals to like b, and then I say like the axis is 1, so it is going to drop the b column here by using the axis 1. But if you will notice something, that actually our data frame is still the same, like there's nothing changed, but it actually, what happens is that it actually drops and returns the data frame with the dropped column or row, and the same thing happens for the appended column or row, and we need to actually save it by using this assignment operator here. So if we want to save it or assign it to df4, the changes, we need to actually set it to df4 equals to df4.drop in the condition. Now we can also use it like df4.drop, and then we can say index equals to 2 and column equals to, and we can say here b. So if we want to drop the column b and the index 2 at the same time, so it dropped the second index and dropped the b column here in one go, and we didn't even have to provide the axis, and actually it's a really great method. Now let's actually talk about saving data. So we can save data in CSV and also in JSON. We can also do it in SQL databases. So firstly, let's have a look here to how we can save our data frame into a CSV file. It's pretty easy. You just have to say df4.toCSV like this, and then tell the file name here, like let me say data.csv, or let me just simply say table.csv, and then I need to provide a few arguments, like if I want the header as well, so I'll just simply say true that I also want to store the headers, and I can just simply say index to false because I don't want these indexes to be in my file, so I'll set them to false. Now if I run this, and let me actually go to here, can you see that what was the name of the file again? It was table.csv. So yeah, if you look at here, table.csv, that abc and all the data is present here in comma separated values. So that's what CSV stands for, comma separated values. So let me close this. So that was how we can save our data frame into a CSV file. Now let's save into a JSON file. So let me just simply say .to.json and then provide the name of the file. So let me say table.json. Now here I don't need to provide anything. Let me just simply run this cell, and if I come back here, I just added a new file here. So that was table.json. So this is how we have stored our table data frame here in the form of JSON, or you can say dictionaries. So that was it, how you can save your own data frame to a file in a CSV format or in a JSON format. Now there is another thing that you can do is, okay, that is called TSV, that is tab separated value. So let me just simply say here table.tsv, and then what I'm going to do is I will say separation. So basically it stands for separation. What should be the separation method? That is commas, or here I have set it to tab, so that represents a tab here. I need to provide the header to be true because I want the header, but I don't want the index, so again I'll just simply say it false. Now let me run it, and if I come here, you will see that a TSV file has been added, and here everything is actually separated using tabs. So the difference between a TSV and a CSV file is that here things are separated using tabs, and in CSV it was separated using commas. Now the next important thing that we need to learn is how we can read in data. So it's quite simple to load data from various file formats into a data frame. So first of all, let's read data from a CSV file. So we are going to read the same table here. So let me say df equals to and then pd.read CSV. So pd.read CSV function is basically responsible for loading a file. So here we need to write the file name. Okay, that's actually table.csv, and I just have to, yeah, and if I say df, it actually loaded our file from the table.csv that we just created in the creation part. Now we can also load in the same way. We can just simply load the JSON file. So we just have to say df equals to, okay, let me create here a new table equals to pd.read json, and the file name, that is table.json, and yeah, and if I say table, it is going to load our model. Now sometimes it may not or might not produce the accurate output like the structure, so you can use another keyword here, orient, and you can find more details about this word on the documentation for Pandas. So for now we can just simply ignore it because mostly it will work. Now CSV does not have indexes like a data frame, so we just need to add another argument here, that is index call, and then set it to 0. So if we have df, like let me copy this again and just simply put it here, and then I say like index call column and then set it to 0. What it will do, you will actually find the difference that it removed our indexes here. Now the next thing is reading data from a SQL database. So if you have data stored in your SQL database, this method is going to help you access the SQL database into a data frame. But first things first, you need to establish a connection between a database using an appropriate Python library. Then you can just simply pass a query down to Pandas, which will help you extract the SQL database into a data frame. Here I'm going to use SQLite 3. So in Python, SQLite 3 is already installed, so I'm just simply going to import it here like this, import SQLite 3, and yeah, it is imported. So SQLite 3, then I'm going to connect my database here by using this line. So con equals to SQLite3 dot connect, and then I'm gonna name here the name of my database. So if you'll notice, I have actually a data.db file here from a web application that I built. Now if I say here, now a connection is created with the SQLite3 database. Now what I'm going to do, now with the help of this con, I can directly run queries here. Awesome. So I'll simply say df equals to pd dot read SQL query, and then I just need to provide the query here. So I'll just simply say select star from users. So there is a table called users here, that's what I'm using, and then I need to provide the con. So if you will see, now I have like accessed the users table, like all the data of users table here in the data frame. So if I say here df, you will actually notice all the data is present here. So it's actually showing the ID, the name of the user, that is the username, then the password, then if the user has the export role or the admin role or the normal role. So for normal, both of them are 0. So this password is actually like SHA-256 encrypted, so I don't need to worry about that. Here showing up. Now one thing I can also do here is I can actually remove these indexes here and use the ID as the default index. So I just have to do it like df equals to df.set index, and then I need to provide the column name. So I'll just simply say ID. And now if you will have a look at my data frame, now the indexes are removed and ID is the default index. Now let's actually insert a table here so we can actually save it back to SQLite3 database. So what I'm going to do is I'm going to create a series here. So I'll just simply say user equals to pd dot series, and then I'm going to provide here like the tester username, and then I'll say password as SHA-256 and some random things, and then it's actually not an admin, not expert, not an admin. So this is our data here. Then what I'll do, I'll set the name to 12. Now also I want to set the index column here. So I'll say here index equals to, and then I'll just simply provide the name, then the password, then admin, and actually and admin was before, and then expert. So that should do the work. If I press shift enter, it creates a series here, and if I say user, yep, so for name is tester, password is this, expert not this, and the name is 12. So let's actually append this here. So I'm going to say like df equals to df dot, okay, first let's check if it works, df dot append, and then user, and we don't want the ignore index here. So that's how I actually added a new user to the data frame by creating a new series and then adding it to the data frame. Now these were all the basic things that you can do with Pandas, but there are a lot of other functions available. In the next session, we are going to learn all the advanced functions.